Hello, my name is Ruben Castano. I'm from TECNALIA, a research center in the north of Spain. And I'm talking about the fourth product that Andrea previously introduced. It is fiber reinforced concrete 3D printing. And we had four main objectives coming into the project. We needed to design a mix suited for 3D printing and fulfilling the requirements of the process. Then we had to add different fibers, both thermal and mechanical recycle, using different fiber dosages to improve the mechanical properties of the material, mainly on the hardened state. Then we had to do some preliminary testing of these mixes, both on the green and the hardened state, to assess the suitability of these mixes with and without fibers, to go through the processes of printing and also to perform during the hardened state actions. And finally, we print a scaled down version of our wind turbine towers with this developed mix, and we will test for validating the material, the process, and also the design of the towers. So the materials for 3D printing have four main requirements: flowability, to heat correctly the pumping system; extrudability, for the material to go through the nozzle and conform a filament; buildability, the property to withstand the weight of the layers on top; and then hardened state strength to withstand the stresses during transport, installation, and service. Here we have four of the mechanical recycled fibers provided by MTD. These fibers came from the same stream, but from different sheets during the recycling process and the shredding process. We have been testing different dosages, as we can see in the right side of the slide, with dosages as 2, 5, and 10%, evaluating the properties both in the fresh and hardened state, as I mentioned before. So for the tower design, analysis, printing, and testing, first we have to design a printable scaled-down version of the wind turbine tower. We have some limitations into the design, so we have to take into account the height of the ceiling in the laboratory where we are printing, 2.9 meters. Also, the size of the nozzle that we are using. It's a nozzle, a round nozzle with 20 millimeters in diameter. Then we have established a limitation of using a minimum of 2 filaments per layer, one next to each other. So this will give us a wall thickness of about 14 millimeters. And then for the testing part, we are able to load about 150 kilonewtons on cyclic loads. So this also has to be taken into account during the design process. First, the design on the left was the first design, a tower that is 2.2 meters high and has a base diameter of 49 centimeters. And the second design was a tower that is much slimmer, and it is 2.7 meters high and has a base diameter of 31 centimeters. Once designed the towers, we have to analyze the performance by running some finite element simulations. And then we start with the printing. Here is a little video of the tower of 2.2 meters high process. And we are going to see some problems during the printing right here, that we have to pause the pump and continue after. This is the final tower once printed, and me for scale to grasp on the size of the tower. And then we will have to test the towers to validate all the material, the design, and also the process. And that will be the end of the project for our part. The main benefits of this work will be that we are integrating the fibers into the towers. We will have to design a material that is optimized for this application, with and without fibers. The fibers will be enhancing the performance of the base material, acting as a reinforcement. And then we have been validating the scalability of this process, because if we can print a 2.7 meters high tower, we will be able to print at least a section of the tower in real scale dimensions. So we will validate that also. And that's all for me. I think I've been a little bit fast, but now we have time for some questions that I already see. Yeah. The loads applied during the FEM analysis were one was the top load capability that we have, about 140 kilonewtons on the upper part to simulate the wind load of a real tower. And then with the smaller tower, we think that we can, with a slimmer tower, we think we can adjust that load to be a little lower and be on the safe side during testing to assure that we can load the towers up to failure. For now, we have not yet done the experimental testing on the printed towers. We have only done on some on the material side, but we will do shortly the testing, and we'll see if the testing validates all the design, the simulation, and the process.
Okay, since we don't have other questions, so we can move to the next presentation from David.
Hello, good morning, everyone. Thank you very much for being here today, and special thanks for coming back after the break. We understand that it's difficult to follow these long workshops, but I think the information we are sharing is quite interesting. I am also from TECNALIA, so TECNALIA has a double role in the Refresh project. Now I will share with you another result we will be delivering in this project related with traceability. So those are some of the barriers that usually are still identified when thinking about wind blade material recovery. This is a typical classification in technical, economic, logistical, market, and regulatory. It's not my intention, and we don't have enough time to go in detail into every one. But just to share with you a couple of them, well, we know that we are dealing with a very complex material. The heterogeneity and complexity of the composites is one of the barriers that limit their recycling and valorization. We are dealing with a material that is still costly to process, and the economic value of the recovered output is very low, so sometimes it's not feasible from an economical point of view to use certain recycling options, etc. For each of those barriers, there is something that traceability can provide. So traceability is the missing digital layer that that we need to facilitate the circularity options for those materials. TECNALIA has been working in almost 10 projects in the last 10 years about wind blades recycling, circularity opportunities for large products made of composites in general. So we realized that one of the things that we need to enhance is the confidence of the final users of those recovered products, and traceability can help us on this. So first of all, traceability. Traceability is a term that for certain companies, for certain organizations, can be limited to fulfill the legal requirements. So they report their wastes, they report a minimum data, but this is not enough to increase circularity opportunities. For us, traceability is the ability to track and document every stage, or at least the necessary stages of a certain product life cycle. So in Refresh project, we have applied this to the stages from the commissioning. So once the blade is on the floor, until the recovered materials have been consumed or reused by third parties. So we think that this turns waste into valuable resources. The tool that we are developing includes the traceability of the blades and all the resulting assets, the resulting materials, components, etc. We record the transactions and changes in the ownership. We can declare and use several processing options with some data from the project for automatic calculations of LCA indicators and others. And of course, we can provide information about the location and tracking of the different assets. This provides several benefits. Perhaps the two most evident at this moment is an enhanced quality control and control in general about the composition and information of those products, and a much better decision making based on actual data. The data that we are using in this platform is based on the project results. That means that for the first stages in the value chain, we are using quite close to market data, the on-site treatment, the first cutting of the blades, the first mechanical recycling. While for those stages that are still at a more lower TRL, we are using some estimations and some preliminary screening data that can be updated in the future. Perhaps the technological insights are not so very relevant for today's audience. Just to let you know, we are using blockchain technology for this platform. But blockchain has some requirements in terms of computation effort, etc. So most of the data are still stored off-chain. We are using some technology for verification of the integrity of the information there. And as more relevant from the user perspective, we have developed a web application that is responsive. We can use it directly from our smartphones, from a desk, from a browser navigator, internet browser. And we are including several functionalities to facilitate that data entrance. So we assume that nobody wants to spend their time entering manually data about the blades and the assets. So most of the information is quite easy to select from some list that are connected to databases that includes blades models, manufacturers, etc. from Spain, south of France, and Portugal until now. The information that is included there, as you can see in this slide, includes the information of blades, manufacturer, and models that is connected with the composition of those blades. We noticed in the past that this is something that is still quite hidden by the blade manufacturers. Even after several years, manufacturers are a little bit reluctant to share information about the details, the drawings, the location of the materials in their blades, but some information is publicly available, so we have included that in the platform. The platform automatically calculates the weights of the resulting assets. We select the most relevant impact categories from LCAs, so the tool is able to provide in an automatic way accurate estimations or accurate quantification of those indicators. And we can see at any time information of the previous assets, processes, and owners for any asset. In addition to this, the users can also attach additional information to any of the blades or the assets. So the tool is already functional. We finalized a first version at the end of last year, and at this moment we are preparing the next validation at TRL 6. So we will use some of the project resources to develop some training and some trials with the project participants. We will try to replicate the different roles we have in the project for the different roles for the platform. In the coming months, we will have additional information from the project results. As you have seen today, we are getting in new updates and new results on the recycling and processing technologies, those creative solutions for repurposing, and also some products using the recovered materials in different quantities. So with all that information, we will update the internal databases. Also based on the user experience and the feedback received from the partners, we will implement further functionalities. And in the coming future, as you know, this project will finalize this year, at the end of this year. We have a compromise to check the opportunities to replicate this platform in other sectors and checking other exploitation opportunities. We know that several traceability platforms are being launching into the market. We also confirm that there are some platforms that covers the first stages in the blades live, but when checking the market options, we realize that no one is covering in such complete way the stages from the end of life of the blades until the recovered materials are consumed in third applications. So this is the presentation of this result. I'm open for any question or comment of this, and if not today, if not now, here there are our emails for further contact and further discussion on this matter. Thank you very much.
Thank you, David.
Okay, I will stop sharing my screen to check if there is any comment.
Yes. Something in chat.
Yeah, regarding LCA, well, there will be a presentation about LCA just immediately after this one, if I'm not wrong. We are considering the user can consider the landfill option for the comparative LCA. But the point until now is that we are including by aggregation the impacts in the different stages. So we can include the preliminary cutting of the blades after their demounting. We can include transportation, of course, all the different processes presented in the previous workshops today. So the mechanical recycling, the recycling based on pyrolysis, transportation, etc. For a comparative LCA, until now we only use the landfill option. Perhaps in the future we can include other common alternatives as pre-processing in cement manufacturing, etc. Yes, until this moment, we are considering the impact derived from the processes, but when we have the final material, we will consider what virgin or raw material is avoided. So we will have a positive impact by that material consumption reduction, and that will be considered in the final figures. You're welcome. I'm not an expert on LCA issues, so if you want any further detail, let me know. I can share your question with an expert on this.
Yes, maybe David, I can comment on this. In the LCA that we perform in the project, we did not consider the original raw material, as we wanted to focus only on the recycling processes, right? So we consider all the energy and other auxiliary materials that were needed for the processes. So we did not consider the original raw material, if Yara intended to ask this.
Okay, thank you very much, Ioana.
Okay. So please, Ioana, you can proceed with the next presentation, which is also kind of linked with this last topic we're discussing, because
yes,
you talk about the stability. So yeah.
Let me share my screen. And okay, thank you. You should see it in full screen in presentation mode. Can you confirm? Yes, thank you very much. So, hi, good morning, everybody. I am Ioana Muntean. I represent RINA Consulting, which is an operational consultancy firm of RINA, a global Italian-based corporation that providing engineering solution, testing, inspection, and certification services. Moreover, we in RINA Consulting are focusing on project management, technical studies, engineering design across different sectors like energy, marine, or infrastructure. I am responsible in the Refresh project about the sustainability analysis for each process and product. And today I bring to you this topic, which is about the Refresh preliminary LCA results that we perform in the first part of the project. So life cycle assessment, it's a study that follows a methodology that follows internationally standardized procedure. So we follow ISO 40040 and 40044 in carrying out this analysis. And we follow the framework of the life cycle assessment, which is composed of 4 phases. So the goal and scope definition, the life cycle inventory, the impact assessment, and the interpretation. So I will spend a few words on explaining you how we set the basis in these phases for the analysis that we perform in Refresh project. So for the goal and the scope definition, we decided that we will have investigated the innovative Refresh recycling processes, and we will have comparative analysis between Refresh recycling processes and linear disposal practices. Then we wanted also to see the environmental benefits that arise from the use of secondary raw materials. And yeah, for this purpose, we also use available literature data, and we set the functional unit of this analysis as 1 ton of wind turbine blades to be recycled. Then moving forward in the life cycle inventory, which is the second phase of the LCA framework, we perform the inventory tables with data that we collected from our partners, from the technology provider partners that you already had the chance to see earlier in this workshop. And we base these inventory tables on high quality experimental data and measurements that was provided directly by our partners by the means of questionnaires. Yeah, for sure, these experimental measurements were obtained through on-site testing. And then we use EcoInvent databases to identify data sets, and we associate data set to each flow that we collected and that we put together in the life cycle inventory. And then for the impact assessment phase, the third phase, we use GABI software, which is a software for life cycle calculation. So we move into the modeling phase, putting all the data and all the flows that we collected in the life cycle inventory table in this LCA software calculation. Then once this modeling phase is completed, we run results, and we use environmental footprint method to run and extract our results, which is the European Commission recommended method for evaluated environmental impact. But we wanted to look only in a few indicators. So we did not look into all 16 indicators because we were interested in looking on the global warming potential, which provide us the CO2 equivalent emission. We wanted to see resource consumption, and we also follow the waste production of these recycling processes, which is an important parameter, right? Because we are talking about recycling processes that we were analyzing in this study. Then finally, in the interpretation phase, which is the last phase of the LCA framework, we wanted to see the hotspot analysis. So in each recycling process, what are the hotspots. So in this way, we can provide a real closed loop of the flow or the process steps that were the most impactful to our technology providers. Then we had this comparison with the linear disposal, and then we elaborate the results to see also the preliminary environmental benefits. So this is a little bit just a diagram that shows the system boundaries that we applied in the life cycle assessment study for the refresh recycling value chain. You can see that in this diagram we can differentiate our partner at ATNOV, which is responsible for the cutting or pre-cutting phase, can apply cutting techniques, whether if we want to pursue a reuse pathway or whether if we want to pursue a recycling pathway. So you can see that in the red rectangle, we have the boundaries of our life cycle assessment, and we basically analyze three recycling value chain through the life cycle assessment methodology. The first one is the mechanical recycling, and the other two are thermal recycling. One with conventional pyrolysis, and the other one with microwave assisted pyrolysis. Then moving forward to some results. So in this image, you can see the results of the recycling versus the traditional disposal method. So basically, in the climate change impact category, all refresh recycling processes show lower environmental impact than landfilling or than incineration. I want to add an additional information. We compare mechanical recycling with landfilling and thermal recycling with incineration because there is somehow some similarity between this type of recycling processes and disposal methods. Recycling produces also secondary raw material that are capable of substituting virgin production. And indeed, this substitution leads to further avoided greenhouse gases emission because we avoid this type of emission because we avoid to produce other raw materials. So moving to my next slide, we can see here that all the recycling routes deliver large climate benefits because, as I said previously, we avoid virgin production. So if you want to look into the mechanical recycling, it's the process that basically delivers the largest net reduction in the order of almost 3 tons of CO2 equivalent. And end of waste material find application in the lightweight industry, replacing virgin epoxy resin. Then if you want to look in the thermal recycling processes, we can see that also this one deliver substantial net reduction, almost in the order of 1 ton of CO2 equivalent for the both type of pyrolysis, and this recycled material can substitute virgin glass fiber, glass and carbon fibers. This is my last slide. I wanted to say that this is just one of the role of RINA in Refresh project, because beyond of this, you see the first presentation of my colleague Daniel Grisenti, which is the coordinator, but RINA has also other activities in the project. But I think that the sustainability analysis is an important activity and role in a research and development project. And yeah, we performed, just to recap, we performed the life cycle assessment of the recycling processes and value chain based on experimental data, and we performed this study according to the ISO methodology. We are performing currently an end product sustainability assessment that includes LCA, LCC, and social LCA of a new wind turbine blade, which is manufactured with recycled glass fiber that is recycled by our partner Gencraft. So with the fiber recycling in Refresh project. And yeah, we are also performing life cycle costing and social life cycle assessment. And by the end of the project, which will be December 26th, we will have a final publication where we will present the consolidated sustainability results of Refresh project. And if you want to have a little bit more detail on these results that I presented in this presentation, there is a press release that you can see, you can find online on project website or on LinkedIn channel, and you can read it and find more details there. I finished my presentation. Thank you. If there are any questions, I will be happy to answer.
Maybe we have
How is the environmental performance comparison mechanical? Okay, we did not have these results yet because basically we performed several iteration of the analysis of the recycling process along the project, right? Because along the project, our technology provider have different developments. So we performed several iteration, and it will be one of our final goal to have also a comparison among the value chain. So compare how performs mechanical recycling with respect with the thermal one. But this will be in the end of the project. So in the first 18 months, basically we focused because we wanted to see whether if the recycling process makes sense respect with linear disposal practices, and also because we had a go-no-go decision with the European Commission, and this was also one of the parameters that was taken into consideration. So these results also supported decision-making for the European Commission in obtaining for the project the go decision that we obtained, because we are here and yeah, we are talking about the recent developments and results. Okay, then I guess I can stop sharing my screen.
Yeah, since we answered all the questions, so I think now it's time for the last presentation of today from Raphael and Anurag on developing markets for recycled materials. So please, guys, the floor is yours.
Thank you, Daniel. We do share.
Are you sharing?
We are sharing, yes.
Yeah.
Thank you, Daniel. Good morning, everyone. It is a pleasure to be here. My name is Anurag Bansal, and I'm from ACCIONA. And today I'm sharing the stage with my colleague and old friend Raphael from EuCIA to discuss a critical frontier for our industry, which is developing market for recycled materials. So Raphael is going to take us through the complex landscape of challenges and regulations that are coming our way. And for my part, I want to show how ACCIONA is moving from theory to practice. Thank
you, Anurag, and good morning, everyone. It's really a pleasure, and just a few words about the spirit of the European project. Of course, we have an achievement, and here we have the grant agreement. It's also a question of complementarity and teamwork. And over the last 3 years and a half, we have developed some very good competencies. You have seen the results already, and it's a real pleasure to share with Anurag, which was for a long time. And then also, I'm very pleased to have this possibility. Look at the title, Developing Markets for Recycled Material. Even 4 years ago, when we launched this project, it was somewhere about what are the possibilities at the end of life of the blades? What can we do? Is it possible to recycle? How can we do that? And over the fantastic work of the partners, we demonstrated it is impossible and it's working. And now we are speaking what is next. And that's really, it's showing the progress. So we'll go to quickly to 2 slides. One is, of course, it's about the challenges. What are the challenges of renewable blades and renewable energy? Because landfilling and incineration are not suitable long-term solutions. We all know that. And when we think that in the year 25, there were around 20 to 25,000 tons of wind blades reaching the end of use or the end of life, depending, we need to address it. Cost and logistics, moving end-of-life blade from one place to even more complicated to another country, sometimes it could take months and months of paperwork. Composite materials, the beauty is durability, homogeneity, lightweight, but also, when it comes to the end of life, it's in the specific value chain. We have limited recycling technology at scale today. Lack of end markets for recycled material, and that's really something we need to address now. Lack of harmonized regulatory framework between the national regulations and the European regulations. So then you see this blue arrow. So what we do next is going to the potential users of recycled materials. There is, of course, the construction market. There is many applications where we can reuse it. But also here there is some common challenges, performance uncertainties. So that's really here we need to look at, is the performance compared to virgin material? Is it something you always compare to what you know? So the virgin is the benchmark. So the regulatory compliance, so we will just have a quick review on that. Traceability, quality assurance, and also standards, methodology, how to compare apple and apple, I would say. Integration, compatibility, just one of the secondary material. How does it bring to fit in my own recipe? Cost value perception. And as Anurag was telling you earlier, it's not a recycled material is sometimes having a lower value in performance and a higher cost. So the equation is not really working. Then we need to have an environment to help us to do that. So regulation could be seen sometimes as a difficulty, as a challenge, but it's also, we see the regulation as a way to stimulate, to facilitate the market, because if we want to pull the market, we need to have some incentives and some regulation framework from the authorities. So just here, it's a quick list, but what is interesting to see is what is moving at the moment, also at the European level. So we are already the waste framework directive, and but now we are, there is in preparation the second raw material market policy with the Circular Economy Act. So especially right now, we need to increase the resilience of Europe. And developing the circularity, reusing the material will really go on that I call the virtuous circle. So the Circular Economy Act, we are working on it, and it's about to create a single market for single-use material and to develop all the good environment to develop it. So it means stimulations, incentives, also support some technology to reach to be reached at scale level. So an example of it's outside of the dates, but as I said earlier today, the end of life vehicle regulation is an example when the European Commission is taking the lead. Here, for example, the next regulation will force the automotive car producers, when they are using plastic, 25% of the plastics has to come from recycled material. Also, EPR stands for the Extended Producer Responsibility, which is always, it's also a way to put additional funding. And here we have the boating industry who has developed a good example, for example, in France, where you have this type of EPR to finance the end of life of the boats. So it's always, we need to create this circle. The Net Zero Industry Act, it's for public procurement, is also here a way where they are addressing the performance in terms of sustainability in their auctions. And so the last things after the regulation, there is also an initiative called the European Circular Composite Alliance, ECCA, where you have all the stakeholders from, of course, the value chain, from raw material producers, tier one, OEMs, also waste management, recyclers, to really address all those barriers, because we need to turn it into actions. And it's, if you want to know more, you have the QR. So that's where we are, and now the environment. Of course, it's not the only things, the regulation of these things. You need to believe on the future, as all the partners here are doing, but it's a way to facilitate the bits.
So thank you, Raphael. Yeah. So we have seen that Raphael has laid out the hurdles very like we face every day in a very good manner. Also, we have seen that how regulations, the coming regulations, will be helping the industry in overcoming some of the challenges and also helping the industry to adapt these material into real world applications. So at ACCIONA, we believe the biggest barrier to adoption of these materials is performance uncertainty. For the construction industry to truly embrace these recycled composites, we have to prove a single point, which is recycled does not mean lower quality. Now, this is why our approach focuses on industrial scale validation. So here you can see that we have chosen 3 demonstrators, but those demonstrators were not selected randomly. We designed them to follow the life story of a decommissioned wind turbine blade. We wanted to see how every single part of that blade could be used again. So it started with prototype 1. When a blade is decommissioned, it is cut and shredded, which generates a lot of fine particles. Usually these particles are ignored. But we are taking these fine particles or milled particles and using them to create pultruded profiles. We want to prove that even the smallest fragments of waste can be integrated back into standard manufacturing. Then we have prototype 2, where we focused on recycled fibers themselves. So here we are working with partners who are transforming these recycled fibers into non-woven mats, and then we are integrating these mats into infusion and protrusion laminate. Now, this isn't just a basic material. It's a high-performance multi-layer laminate that is going to substitute virgin chopped strand mat, which are currently being used. And finally, we bring it all together in one prototype, which is the prototype 3, the deck formwork system. Now, this is our most ambitious demo because it combines everything. it uses the profiles from demonstrator 1 and integrates them with compression molded panels from GE's recycling, and which are made using shredded blades. Now, since formwork is used on almost every construction site, it is a perfect real-world test for strength and durability. Now, to conclude, I would like to tell you where we are. Right now, these demonstrators are under construction. Once they are ready, they will be installed and monitored in real environment to measure exactly how they perform. Our goal is to prove with hard data that we can replace virgin material without sacrificing an ounce of structural integrity. At ACCIONA, we aren't just recycling. We are transforming old blades into high-value assets. We are turning a waste problem into a circular solution. Thank you. So now we are open for any questions.
Thank you for listening.
Thank you.
Slides will be available, yeah, because I will put it on the website, I guess. Okay. So we have finished the presentation part. Now we have last space for questions and answers if you have one. So
Does ACCIONA still have a partnership to make sneakers with? Yes. In fact, we have the second edition of the sneakers.
Your share your slide.
Yes. Would ACCIONA share it only qualitatively how recycled material fare means? Right now we are within refresh, as I mentioned during my presentation, that right now we are developing those demonstrators, and once the development is done, we are going to construct them, install them, and then we will be doing on the test. And once the tests are done, we will definitely have those values, those figures.
Yes. Maybe we can share now some views from our partners on this question from Alexander Force. We haven't answered yet. We left for now because it's kind of for some spiral discussion. So you want to share your insight?
Challenge preventing circular end-of-life solutions. Two aspects. The first one is the ever hard obstacle to introduce something new and something that was never done before, and that's probably one of the most hard to most important obstacles in the field. Like construction, for example, where that is really based on even century-old technology, and so it's very hard. But anyway, the other question is that a circular solution need to be understood and competitive. The other important aspect is that in some way the circular solution changes transform the playing field. So very often there are obstacles also because, for example, particularly in big companies, it's difficult to talk at the same time with the purchasing department and the environmental or sales department, because normally are completely separated, and so it's it will take time because every new supply chain needs time to develop, to establish, and to create connection. I think that a project like Refresh and then also other European projects may have the important function in showing and demonstrating what is possible to do, and so create the path. But then someone needs to work this path.
Maybe I would add one thing also, Giorgio, as the question was specific about offshore. I think logistic when handling the end of life of the base would also be something as a challenge.
Right. And I think you already covered those challenges.
Yeah, true. More important than ours.
Yes, offshore it's another complex. So we need to understand that also offshore is starting now becoming a question. As I know, there is probably next year will start the decommissioning of the first offshore wind turbine park. So it's completely new. I think that it's surely a place where innovative solution may find a lot of sense. Even, for example, the commissioning practice that we are demonstrated in Refresh, I think that could be really interesting to process. In this case, to process the blades instead of in a field, to process the blade in a ship, just to optimize the logistical part. Logistic in offshore is always, in every kind of offshore, logistical is key. So I think that we may have a lot of potential opportunity. We are also, for example, talking, if we think to an Ecolab, we are floating a way to We are developing a way, for example, to convert, to transform the syngas generated from the composite waste in methanol. Methanol may be used now. They are already starting testing, trialing, for example, for ship propulsion. So, if we think to the near future, 5 years wouldn't be really strange to have offshore vessel powered by the composite waste from the wind blade, or part of the composite waste from the wind blade. Still a lot of work. The refresh is probably, it's a really big, strong point, but it's a starting point.
So answering to the question from Marco, at ACCIONA, we have developed our own in-house low temperature continuous thermal recycling technology for recycling wind turbine blades. Currently, the capacity is 1,000 tons, and we are increasing it because we have got a lot of demand coming in. So we are increasing it to 2,000 tons, and eventually we plan to increase it to 10,000 tons by 2030.
Okay. So thank you everyone for this final discussion. I don't see other questions, so I think we can close it here. So I wanted to thank you everybody for attending, for asking questions as well. You will find the presentation on our website, which will be downloadable. So thank you very much again for attending, and have a nice day. And goodbye, everyone.
Thank you.
Bye-bye. Thank you all for attending.
Thank you to all.
And thanks for the attention, and
Bye-bye.
also
Thank you.
for the intelligent and precious questions.